Here we are going to discuss about cumulative frequency curve. Cumulative means sum of the previous one. Okay, sum of the previous one. Okay. Um, I will use an example. As a person, you have, okay, this is you. Let's make this person as X. Okay. This person in his hand, he is holding a bag. Let's assume this one as a girl. Uh, she has a bag, and in this hand she has a purse. In her neck she is having a backpack. Okay, cumulative means first of all she is having a handbag. Okay, she has this one. Thereafter she has purse. She has backpack. She has wearing a shoes. Okay, a pair of shoes. Okay, all together we can individually analyze this person by their belongings: handbag, purse, backpack, shoes, and their caps, and whatever they want likewise. So, all together is called as cumulative. Cumulative means sum of everything. Sum of everything. In simple words, we can explain the cumulative as sum of everything which we hold, that is called as cumulative. But in mathematics, not like that. Let's use a table of data, grouped intervals. Okay, the topic is cumulative frequency curve of a group data distribution. So previously the data was already grouped. By using that group data, we are going to produce cumulative frequency curve. It is really simple. Okay, try to understand what I'm explaining. First, what we need before plotting this cumulative frequency curve. This is not a straight line. It is a curve. Okay, in the topic you have, this is a curve. Class intervals. As usually, you need class intervals and their relative frequencies. And not only that's enough, you should produce one more column as well. Okay, let's have a look into that one. First of all, the class interval. Here we are going to produce the cumulative frequency curve. So for that, you have to draw one more column that is showing the respective cumulative values. Okay, cumulative frequency values. I'll mark that one as CF. Okay. In this statistical part, we are using F for frequency, CF for cumulative frequencies, CI for class intervals. So cumulative frequency means directly you can write already only the frequency is 3. No, directly write the 3 itself. Next, what you should do is 3 should be added with 7. Already we had 3. Now additionally there are some other frequencies will be joined with the existing frequencies. Already 3 is the frequency. With that, there is an addition of 7. So 3 plus 7, it would be 10. Thereafter, another 8 is joining with them. So 8, 10 plus 8, it would be 18. Thereafter, another 2 is joining. 18 plus 2, it is 20. Then 20 plus 4, 24. 24 plus 6, it is 30. I told you, as I mentioned earlier, cumulative frequency means sum of existing values. So already initially we had only one value. So that is the cumulative frequency itself. Thereafter in the second interval, look at this. Previously we had 3. Now there is an addition with 7. So 3 plus 7, it is 10. Again all these 3 together. So it is 18, then 20, 24, 30. Likewise, this is the way you have to produce your cumulative frequency column. That means existingly we had 3. So that's why the first cumulative frequency is directly 3. Thereafter, you should include the newly added values together to produce cumulative frequency column. Now let's draw these values in the cumulative frequency curve formation. In cumulative frequency curve formation, you will have the x-axis and y-axis. Both together will produce the respective curve. Okay, I will draw and then after I'll explain. Okay, this is our curve formation. First, we are having The minimum class interval is 0, no? 0, thereafter 10, 20, 30, then 40, 50, 60. Okay, up until 60 it is totally enough. So in the horizontal axis we are showing the upper limit of class intervals. Okay, upper limit of all class intervals that should be shown in the horizontal axis, not the class interval. The class interval case only belongs to histogram and frequency polygon. Now we are talking about cumulative frequency curve. Yeah, the major concerning factors would be upper limit of each class interval. That's what you have to show here. Upper limits of class interval, CI. Okay. Thereafter, in the vertical axis, you have to show the frequency, not this frequency, cumulative frequency. This graph is all about to produce cumulative frequency curve. Uh, so here we have until 30. So I will split this into 5, 5, 5, 10, 15. For your convenience, you can split 20, but you should keep same distance between all these following values 20, 25, and 30. Okay, it's simple. Next, just mark the coordinates. Just mark the coordinates on this plot. First, upper class limits of each class interval that was plotted in our horizontal axis, in our vertical axis, cumulative frequency. I will repeat this again. Not we are going to produce the bars. We are just producing dots. Thereafter connecting those dots to create a curve. So maximum values, class upper class limits in each class interval in our this axis, and thereafter cumulative frequency. When the class interval, you should use only the upper class limit. Okay, upper class limit 10. When the class interval's maximum value is 10, the cumulative frequency is 3. So 10 and 3, the first coordinate would be along 10 and 3. 3 means little beyond this 5. Okay, first this would be the one. Wait, I will use like this. This is my first coordinate. Thereafter, next coordinate would be 20 and 10. Second class intervals, upper limit, and corresponding cumulative frequency 20 and 10. 20 and 10 means exactly here. Then upper class limit and corresponding cumulative frequency 30 and 18. That means that is greater than 15 somewhere here. Okay. Thereafter, next one would be 40 and 20. 40 and 20 directly here. Okay. Yes. Then 50 and 24. Upper class limit and its corresponding cumulative frequency, it is 24. That is little less than 25. So here, somewhere here. And thereafter, we have 60 and 30. 60 and 30, that is the last point. Yes, yes. Okay. By using these points, we are going to produce our cumulative frequency curve. Okay. By using the grid lines, we have produced the exact points in this cumulative frequency plane. And we are going to connect all these points to produce our cumulative frequency curve. Our purpose is to show how this is increasing. So when you plot only the histogram of frequency polygon, that is limited. Okay, that is showing, okay, this class interval belongs to this one is this, but that is not showing the continuation. That's showing the each representative blocks to show the intervals and their relative frequency. Cumulative frequency will give you the vast range of idea, the overall virtual idea from these class intervals and their respective cumulative frequency, the total one. The total interpretation of all the values consist in between these class intervals. So upper class limits were shown here. Thereafter, we just used cumulative frequencies on the vertical axis. Thereafter, what you have to do is we just plotted the exact points, exact points. Thereafter, starting from 0, you should use to draw the curves. Okay, this would be the curve. This is showing the cumulative frequency of this particular given class intervals and their relative frequencies. I will repeat it again. So just plot your exact points in this diagram. Okay, no, in this plane. Thereafter, starting from 0, don't use rulers or any kind of equipment. Use your hands to draw this one as a curve. Sometimes it will have some kind of peak like this. You will have a small peak here. Sometimes you will have the graph like this. Sometimes like this. Okay. According to the values, it is changing. So this is the production of cumulative frequency curve for our first set of. As I mentioned before that, while drawing the cumulative frequency, you have to draw the precise points, okay, precise location of each coordinates. Yeah, the upper class limit and the corresponding cumulative frequency precisely mark the point. If not, from this graph, you should extract some data Q1, Q2 and Q3. At that time, you may struggle because if your values are not precise, your graph is incorrect. From the incorrect graph, we cannot extract any data from there. So please be careful while drawing these graphs. Don't use any rulers or anything. Use your hand to show this curvature. Okay. So the cumulative frequency, it would be first 1 itself. Thereafter 1 plus 3, it would be 4. 4 plus 2, it is 6. 6 plus 2, it is 8. 6 plus 2, it would be 8. 8 plus 1, 9. 9 plus 1, it is 10. So the cumulative frequency, that task is over. Only thing we have to do hereafter is producing a cumulative frequency curve. The planning is really important. 0 until 30. 0. Keep the same distance between these values. If you want, I can show you by using a grid. In this axis, in the horizontal axis, we are just showing the upper limits of class intervals. Upper limits of class intervals. In the vertical axis, it should represent cumulative frequency value. Okay, so the axis consists of 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, these are the cumulative frequency values. The maximum is 10. Then let's mark our coordinates. Let's mark the coordinates. First coordinate 5 and 1. The upper class limit and corresponding cumulative frequency 5 and 1. Here, first point would be here. Second point 10 and 4. 10 and 4 exactly at here. Thereafter 15, 6, 28 just here and 25, 9, 30, 10. 25, 9, 30, 10. Okay. So now let's connect them. Starting from 0 like this. This would be the curvature. My one also little incorrect. Wait. There is a spike, no? Yeah, the sudden spike. And thereafter this is gently going. Okay, this would be our cumulative frequency curve. That's all. Our work was done. In the horizontal axis, upper limits of class intervals; in vertical axis, cumulative frequencies. Do not connect them as straight lines like this. Okay, that is incorrect. Somehow it should be a curvature. This is fine. Thereafter, by using this, we are going to analyze first quartile, second quartile, third quartile, and interquartile range. Okay, first quartile, second quartile, third quartile, and interquartile range. That's what we are going to analyze from this frequency polygon. I will explain what is meant by first quartile, second quartile, and those things. Okay, first quartile means first you have to identify what is meant by quartile. Quartile means, okay, in a circle, how many quartiles it has? It has totally four quartiles. First, second, third, fourth. Likewise, quartile means one fourth. One fourth. So in this cumulative frequency curve also, we will have totally three quartiles. First, second, third. There is no any fourth. Okay, fourth would be the last one. So we are not going to consider about that one. Fine. First quartile, what you should do is, that is first quartile. First quartile means we are using Q1, a letter Q1 to show quartile. First quartile. One fourth. First quartile means one fourth of this total cumulative frequency. What is the total cumulative frequency accumulation? That is 10. So one fourth of 10th. One fourth of 10th. So it will give you 10 divided by 4, 2.5. 2.5. So 2.5 place will give you corresponding Q1 value. So to find the Q1 value, what you should do is, in the vertical axis we have 10, 9, 8, something likewise. No, to identify Q1, one fourth of this total. So that is showing the exact 2.5 place. 1, 2, this would be the 2.5 place. Across this, draw a straight line. Draw a straight line. Where this straight line intersected with our frequency curve, that at that place you should draw another straight line towards your horizontal axis to identify the exact value. Exact value. It is located in between 5 to 10. So sometimes it is not 6 or 9, somewhere 7 or 8. So I will take this value as 8. So the first quartile range value would be 8. First quartile range value would be 8. So how I identified first quartile? Q1. The representational notation is Q1. One fourth. Quartile means one fourth of total cumulative frequency, that is 10. So one fourth of tens will show 2.5th location. Through 2.5 in the vertical axis, just produce a straight line. Where that is intersected with our frequency curve, across that you should find its corresponding horizontal coordinate, that is 8. So this is the way you have to identify Q1 values. And second one, second quartile. First quartile and second one would be second quartile. According to your diagram, there might be some little deviation. Q2 would be second quartile, no, 2/4 of cumulative frequency. 2/4 of 10th. 2/4 of 10th. First quartile means 1/4. Second quartile means 2/4 of 10th. So that will give you exact location. 2 times 10, it is 20 divided by 4, fifth. So across fifth, you should produce a straight line. Across 5, you should draw a straight line where this is intersected with our frequency curve. That's why I told you make it as a curve. If you used to plot that one as a straight line, your value is incorrect. Okay, your value would be incorrect. Look at this. There are some incorrections with our curvature. No? So that's why you should produce that one as a curve. That is a must. Thereafter, producing from 5 its corresponding x coordinate. So it is lies somewhere in between 10 to 15. It is not 11 or 14 or 13. Around 12. I will take this one as 12. Okay. So second quartile, it is 12. Second quartile value we obtained was 12. Simple thing. Then you have to find one more, that is our third quartile. Third quartile. The representational notation for third quartile is Q3. Q3. 3/4 of tenth. 3/4 of tenth. 3/4 of tenth means 3 times 10, it is 30 divided by 4. Exact 7.5th location. 7.5th location. So through 7.5th location, draw a straight line. So here, in between 7 to 8. Okay, draw a straight line where this is intersected with our cumulative frequency curve. Through that, draw a straight line. So it is around exactly in between 15 to 20, around 19, near to 19. No? So I will consider this value as 19. So our third quartile value was 19. So from the beginning, I will explain. After producing the frequency curve, one more thing to analyze in this curve. That is first quartile, second quartile, third quartile, or one more thing, that interquartile range. Those are the four quadrants you need to identify. First quartile means the representational notation is Q1. Q1. 1/4 of total cumulative frequency. 1/4 of tenth means 2.5th location. That will give you across 2.5th location. This is not directly our first quartile value. Across 2.5th location, you should produce a straight line and find the corresponding horizontal axis value. Same thing for second quartile. There is a similar name for second quartile, that is called as median. For other first quartile and third quartile, it doesn't have any specific names, but second quartile, it can be called as median. Sometimes median. Okay. Third quartile, Q3, 3/4 of total cumulative frequency. So that will give you 7.5th location. Across 7.5th, draw a straight line, and where it is sliced, through that produce a vertical line to identify exact location where it is cutting our upper limit of class intervals axis, that is 19. Then finally, interquartile range. Interquartile range, I will write here. Interquartile range. So the interquartile range would be Q3 minus Q1. After finding Q3 and Q1, when you subtract those values, that will give you interquartile range. The Q3 value means not 7.5. Okay, across 7.5, you have produced a straight line to identify the exact value for third quartile, no, which is 19. From that 19, you should subtract Q1. Q1 value was 8. So 19 minus 8, that is 11. So this is the value for our interquartile range. Interquartile range. If your curvature is incorrect, these values may differ with 1 or 2, not much, with a little bit, 1 or 2, that is enough. If you got your Q1 as 7 or 8 or 9, that is acceptable. Q2 as 12 or 11 or 13, somewhere here, this is acceptable. And Q3 18, 19, 17, 18, 19, somewhere, that is acceptable. Okay, you will not get the same value as mine, because there might be some incorrection, human errors. Okay, while producing the curvature, your curvature might be little deviated than mine. So that's why the little deviation is acceptable. First quartile, second quartile, third quartile, it may differ with 1 or 1.5 values, that is acceptable. The interquartile range also, it might differ. It can become 9, 10, 11 or 12, somewhere in between this range, that is acceptable. So while correcting your papers, they will not exactly rely on the marking scheme. According to the student's perspective, your curvature and your answer might be in a particular range. That's what we are expecting. That's all about this cumulative frequency curve.